In today's video, we'll be learning how to determine whether a molecule is polar or nonpolar. The question asks, how many of the following molecules are polar? The first step in solving this is to draw the Lewis structure for all the molecules. Once you have the Lewis structure, you may identify the bond dipoles using the differences in electronegativities. Once you identify the bond dipoles, you then identify if there are any net molecular dipoles based on the molecular geometry. We will start with sulfur trioxide. The first step is to draw the Lewis structure, identified here. Sulfur trioxide has 24 valence electrons, which we will check in the Lewis structure. After you draw the Lewis structure, we see that sulfur trioxide violates the octet rule, which is an allowed exception. After looking at the Lewis structure, you can determine that the molecular geometry for the structure is trigonal planar. You then draw the molecular geometry with the dipoles. Using the electronegativity, we know that the sulfur has a partial positive charge here, and the oxygen atoms have partial negative charges. Therefore, the dipoles start on the sulfur and point toward the oxygen atoms. Because we have a trigonal planar molecule, the three dipoles are equal to each other, so they cancel out. Therefore, there is no net dipole, and the molecule is nonpolar. Next, we have oxygen difluoride. We start by drawing the Lewis structure located here. Oxygen difluoride has 20 valence electrons and does not violate the octet rule. Because the oxygen atom has two domains and two lone pairs, we know that this molecule has bent molecular geometry. The oxygen atom has a partial positive charge, and the fluoride atoms have the partial negative charge. Therefore, the dipoles point toward the fluoride atoms. Because there is bent geometry, there is a net dipole located here. And therefore the molecule is polar. Next, we have beryllium dichloride. Again, we start by drawing the Lewis structure. Beryllium dichloride has 16 valence electrons, and it violates the octet rule. Because the beryllium atom has two domains, the molecule is linear. The beryllium atom has a partial positive charge, and the chloride atoms have partial negative charges. Therefore, the dipoles point towards the chloride atoms. Because the molecule has linear molecular geometry, the dipoles cancel out, and the molecule is nonpolar. Next, we have calcium tetrachloride. We start by drawing the Lewis structure located here. Calcium tetrachloride has 32 valence electrons and does not violate the octet rule. Because calcium tetrachloride has four domains, it has tetrahedral molecular geometry. The tetrahedral molecular geometry, the dipoles cancel out, making this molecule dipolar. Lastly, we have ozone. We start by drawing the Lewis structure. Ozone is a structure that experiences resonance. Therefore, it has a resonance hybrid structure. The ozone molecule has bent molecular geometry. The center oxygen atom has a partial positive charge, and the two outside oxygen atoms have partial negative charges. Therefore, the dipoles point outward from the center atom, and there is a net dipole. Because there is this net dipole, the molecule is polar.